This is enabling serverless teams. So these are best practices, practical, hard-won lessons for leaders seeking to empower teams building serverless architectures on AWS. My name is Austen Collins. I'm the original creator of the Serverless Framework. I've been a cloud architect for many, many years. And when I saw that AWS came out with AWS Lambda in 2014, I thought to myself, that the model of how we build applications on the cloud is changing. And it's shifting from, we kind of build everything, code everything ourselves in virtual machines to we outsource more to highly efficient cloud infrastructure that's auto-scaling and offers higher levels of abstraction that actually solve business problems rather than kind of lower level infrastructure concerns. And when I saw this kind of happening in the cloud, mostly inspired by AWS Lambda, I thought to myself, I'd love to build all types of applications on AWS Lambda and perhaps build applications that just auto scale and have really low overhead as a result. So I created the Serverless Framework in 2015, early 2015, and it caught on and struck a huge nerve with the developer community. I think developers love the idea of building serverless applications with radically low overhead that are auto scaling and also are only pay per use. So that was 2015. After the Serverless Framework started catching on, I incorporated a company called Serverless Inc. And we are a team of almost about 40 people, fully distributed today. And we focus on tools for developing and monitoring serverless architectures, mostly on AWS as well as some other services. And so if you are interested in working at a company that has, if you love developer tools, if you love cloud, if you want to be on the forefront of kind of where cloud is going, feel free to reach out to us. Here's my contact info right here. You can find us at serverless.com. Thanks for all these greetings here. I'm getting overwhelmed by greetings in the chat. I don't know if I could maybe turn off these notification sounds. Oh, there we go. Got it. Okay, first off, warning. Big warning. This is not a webinar about shiny new AWS services. The bleeding edge, the new stuff, the cool service configurations and patterns, hacks that people are doing for lowest total cost of ownership or for really cheap, pricing. This isn't really that talk. This talk is more based on hard-won pragmatic lessons for technical and business leaders considering serverless architectures for these two goals: increasing productivity and reducing the carried costs of their software for their team and their business. Right. So there's I've been doing serverless for maybe over 6 years now. And I have seen an incredible amount of patterns and different types of architectures in the serverless world. And these are my personal kind of favorite takeaways from that experience. Serverless Inc., I think we've had some of the greatest serverless architects kind of cut their chops at our company and move onward and upward to greater things. And I've just been around and been able to see how people apply serverless architecture so many different ways. And this is kind of my personal takeaways and a lot of our teams as well as to best practices for really pragmatic serverless architectures for leaders in particular. Real quick, Serverless Framework, a quick overview. It's an all-in-one development, monitoring, as well as support offering for serverless architectures on AWS. So since launching in 2015, we recently surpassed our 40,000 GitHub star mark, which is amazing. I never would have thought this project would come so far and change the industry and perhaps the cloud as we know it in the early days. But it's the unofficial serverless engineering standard across global 2000s and startups alike. Every single day, hundreds of startups are starting their journey on a serverless architecture via Serverless Framework, and global 2000s are spinning up Serverless Framework in their org to rapidly innovate and reduce overhead. The tool itself takes the form of an open source CLI. You can find it on GitHub. Just search Serverless GitHub, and you'll find this fantastic open source CLI that gives you a YAML file that tells a simple story of functions and events. You simply declare your functions and write code, logic, to perform some type of work and add events that trigger that logic to run. I think this simple story of functions and events right here really made serverless architectures accessible and approachable for developers at large. And it continues to grow this pattern and support all types of great serverless architectural patterns. You could hook this up. You could build serverless applications using this application model. You could build REST APIs, GraphQL APIs, async processing, queue processing via SQS, pub sub via SNS, event-driven workflows using Event Bridge. The sky's the limit with this. This is really all you need to build auto-scaling serverless applications on AWS without having to be a cloud expert at the end of the day. And that's kind of the big draw of the framework. With that open source CLI, we do have a hosted dashboard, the Serverless Framework dashboard, which is designed to be everything teams need when you're scaling a team and you have multiple people collaborating on serverless applications, or you're going into production and you need sophisticated monitoring, troubleshooting, debugging capability. So Serverless Framework open source CLI will get you really far, but right when you start scaling a team and you have to figure out, oh, how are we going to standardize this team and make sure everyone practices serverless development in a common unified way, or how are we going to make sure we have alerting set up and everything is instrumented correctly and charts and graphs on all the aspects of our serverless architecture. The dashboard is great, and we have a huge free tier, probably the biggest free tier there is across all the monitoring products. So you can get started with it right away. As soon as you sign in via the Serverless Framework CLI, you'll see and deploy and start interacting with your app. You'll see the dashboard come to life. And our whole goal there is we instrument everything automatically. We set up alerts automatically. You should be ready to go into production after your first deploy, because that's kind of our vision for the way we think serverless should be. So check it out. Furthermore, we haven't announced this yet, but we will announce this in a couple of weeks. But just to give you some sense of where we're going. More than ever, serverless is kind of taking over the cloud, and we are revamping our entire dashboard to be a more sophisticated operations console for team collaboration, access management across your AWS accounts and other vendors, as well as really sophisticated monitoring, troubleshooting, querying capabilities, logging capabilities, log searching. We have a brand new vision for this, just based on how much serverless is growing. The use cases are growing, and we're delivering a new project called Serverless Console to cover this. And it's going to broaden the scope of what we covered today. It's going to include serverless containers running on a serverless service, as well as a lot more AWS infrastructure. So look out for that. We're going to announce this in a couple of weeks and start sharing the private beta pretty soon. And lastly, if you all haven't seen this, we recently announced Serverless Cloud, which is our first application platform for where we effectively host the applications. And this is, if you're looking for a developer experience, if you're a developer just looking to build faster than ever with probably the fastest backend development experience on the market, there is nothing that comes close to this. We've gotten deployment speed down to 500 milliseconds. We've created a concept of forkable applications where you could easily clone any instance of your application. It is really incredible. So we're going to launch a public preview for Serverless Cloud. It's in private preview right now. You probably can sign up and get access right away. But we will launch a public preview in about a week. So just a heads up on that. So serverless. Let's get into the basics. Let's start with those, the who, what, and why, especially. And I'll start from the top here. So what is it? What are we talking about? Yeah, I think what's happening after kind of watching this for several years is that the traditional app server, where we used to build everything in code and build these huge monolithic code bases that were difficult to scale and wrap our heads around, we're kind of unbundling that app server and outsourcing the parts to new cloud services to scale and maintain them so we don't have to. Right? So we're kind of taking all these pieces that we used to write ourselves, build ourselves, and maintain and scale ourselves, and outsourcing them to a next generation of cloud services that solve those specific problems. And the goal of this, and what this looks like at the end of the day, is this. This is a great serverless architecture diagram from our friends over at Theodo. Theodo is a fantastic serverless consulting firm. If you're looking for services to help you build serverless architectures, we can't recommend them enough. And they delivered this serverless architecture diagram a little while ago, and I think it's one of the best architectural diagrams I've seen. But here you can see what used to be encapsulated in our code has been unbundled and kind of outsourced to these various services on AWS. And starting from the top, we have kind of a users and authentication service. So you have kind of centralized auth, which a lot of other components can reuse. You have your business API right here for all your basic request response flows. You have website hosting on S3. You have using your domain and SSL certificates handled via Route 53 and ACM. And then there's EventBridge, which is handling all the asynchronous workflows, as well as step functions for doing kind of stateful workflows. And so this is a fantastic diagram. By the way, all this will be posted and shared on YouTube, and we will be doing a live Q&A at the end of today's presentation. So if you have questions, we're going to save 15 minutes at the end here, so you could ask anything you want to know about the subjects, the material I covered. But you could see this, capture this on YouTube, or search for Theodo Serverless Architecture. They did a Medium post on this where you could pull up this image. And this is a fantastic one. This is a great architectural diagram. But you can see there's a lot of services here. And why are we doing this? Well, the goal is to deliver software with radically low maintenance requirements. Really low overhead is what we're going for. We are after set it and forget it architectures ultimately, so that we can walk away and work on other things, or lay on a white sandy beach, whatever is your preference. But overall, the goal is to reduce overhead. And in that, we will liberate productivity and creativity. And I will tell you, I see this every single day with users of the serverless framework. I've seen it for years. And it's truly incredible when serverless teams catch their stride, because once they get things figured out, the amount of productivity and the innovation that happens is, to be frank, it's the thing that gets me out of bed in the morning after doing this for so many years. But we have organizations that are doing tens of thousands of AWS Lambda functions now, incredible amounts of logic and whatnot by very small teams. And that's one thing I really appreciate about this, is you don't need to have a large organization and a lot of resources to deliver an incredible amount of output. This is truly, these are, I think, some of the greatest building blocks of our time. If you're a developer, if you're a startup, or if you're an existing Global 2000 who needs to innovate quickly. Where is this useful? Serverless architectures, our opinion is it's a great fit for greenfield new initiatives. So these are net new projects, not as much migrations. Migrations can involve a lot of rework to map your existing kind of monolithic applications. Usually the legacy stuff is more monolithic, to all these services, these new services. It's kind of a big operation. But plenty of people have done it, and they think that the low total cost of ownership is the incentive, is a good enough incentive to do that migration. But overall, if you're focused on innovating, reducing time to market, reducing total cost of ownership, those are your key priorities. And generally, if you're doing greenfield or net new initiatives, absolutely serverless. I just couldn't imagine doing anything else. Especially today, it is an era of hyper competition. And I'll tell you, I just don't see how companies are going to keep up, let alone lead in this era of hyper competition, if they're going to continue to try and build and maintain every aspect of their software stack. There's just no way. I think that's kind of a fool's errand at this point. And you can see how the industry is responding to this. AWS, other cloud platforms are becoming more and more serverless. Our default position in our company is that serverless is the natural evolution of the cloud, and the cloud pretty much has nowhere else to go other than to offer more services, higher levels of abstraction that solves every single business problem you could have in life, and does it in an auto-scaling, pay-per execution, pay-per-use manner. That seems like exactly what the cloud needs to do in order to enable more people to build more software. So we think it's useful for anything that you're doing that's new, and especially if you're innovating, reducing time to market, and you care a lot about reducing carried costs. Yeah, I've been doing this for several years, and yes, I'm biased, but I have to say I still couldn't be more motivated than I was when I started all this in 2015. And the reason for that is the results are real when I see people leverage a serverless architecture. And I will say another thing, going through the pandemic and everything we went through in 2020, I think that there's a new norm out there. It's not just hyper innovation, hyper competition, it's hyper volatility. And there are times when certain industries could be shut off now in an instant. And going through that and seeing what our customers were able to do with serverless architectures was incredible. I came out of 2020 just with renewed confidence for serverless in general. A couple examples, everyone talks about scaling up in serverless architectures, but it turns out if you have to shut down your business immediately, scaling down is the most important thing. And so we had businesses that had to scale down. Maybe they're doing live events or something like that. And they reduced all their infrastructure costs to zero without having to do anything. And that was at a time when they needed the cost savings most, which was really interesting. Um, Furthermore, given, if you're an IT leader, a technical leader, given all the changes we're seeing across teams, people switching jobs, people taking a break from work, I think more than ever, it's a great time to consider maybe not building and maintaining every aspect of your software stack at your company, outsourcing, focusing on only the parts of your business that actually provide you differentiation is key, especially if you're seeing a lot of team transitioning. It is much easier for new people to come in and pick up things when your kind of areas of ownership are minimized. So let's get into teams and enabling serverless teams. So, there's plenty of challenges and drawbacks with the serverless architecture. As with any technology, there's no silver bullet. Those just don't exist in life, unfortunately. Maybe I've just gotten old, but it seems like there are no solutions. There's just sets of trade-offs. And some of the big trade-offs, I think some of the root causes of most of the complexity in serverless architectures are, number one, some people call it serverless and some people call it serviceful, because serverless architectures at the end of the day are distributed systems in which you're trading code for cloud infrastructure. And as a result, this architecture features more cloud infrastructure and then configuration for all those different pieces of infrastructure than any other architecture out there. And that's a big transition for people to make, shifting from code over to cloud infrastructure and how they secure that, how they create repeatable, scalable patterns on that cloud infrastructure, how teams collaborate on that cloud infrastructure. These are pretty new and interesting challenges in the serverless world. Second, these services are cloud only. So you're building on services that only exist in the cloud, spinning up all these services locally on your machine like you used to with the traditional technology stack just isn't a super viable option. And I'll get into the reasons why. So you have to shift to kind of a cloud first development model using a lot of cloud infrastructure and figure out how to get a team to collaborate on all that. So there are plenty of interesting meaty challenges there to solve. And of course, if you could get over those challenges, you result in a place with really reduced overhead and tremendous productivity. And if there's nothing else that you take away from this webinar, I think it should be this. I think it's if you're a leader, if you're leading a serverless team, and you have a serverless strategy and you're starting to scale your team or kind of go into production with something, I think the hallmark, the defining quality, the difference between the serverless leaders and contributors is that the leaders tend to think in patterns and contributors think in parts. This is huge. Every single day, if you're the leader of your serverless organization, your serverless team, your developers are going to be coming at you with all the best intentions, and they're going to say, we need to use TypeScript right now. We need to use Rust. We need to use this new AWS service that just came out. And reInvent is coming up. We're about to be bombarded with a ton of new AWS services. And a lot of very excited developers are going to want to bring those into your architecture right away. But if you're the leader, the most important thing you must do is look at the whole, not the pieces. Look at those patterns and think at the level of patterns. That's going to set you up for success. And to clarify, offer some clarifying principles on what I mean by that is, first off, you want to focus on being minimal. Adopt patterns that have the lowest total cost of ownership across architecture as well as team workflow. As the team leader, you're not just going to be looking at the architectural kind of TCO of a new pattern or a new technology or whatnot. You really need to look at how the team adopts it and how fast, how you can maintain a high velocity with this new technology and with this new pattern. That's your job. And so you have to look at it a bit differently than the individual contributors will look at it. And I'll tell you right now, with serverless architectures, there's a ton of serverless cloud infrastructure now. It's fantastic in configuration options and whatnot. And there's hundreds of patterns. There's a ton of patterns. It's been, given the pace of innovation we're seeing in the serverless domain, it's been hard to really nail down kind of the best patterns for everything because everything is changing so much. But that brings me into my next principle here, and that's just be consistent. Adopt patterns in AWS services intentionally, and stick to them. Consistency is key. It makes your system approachable, predictable, and repeatable. Again, if you encounter a lot of new infrastructure services and technologies and whatnot, I'd say some of the biggest challenges we've had at our own company is the technology playground effect, but more specifically the AWS technology playground effect, where we're trying out all these new things because we love serverless architectures and infrastructure so much. It's created just inconsistency across the board in some key services. And so, whatever you do, yes, there's going to be new things that come out and they seem very enticing to bring into your architecture right away. But as a leader, it's most important to keep things consistent and predictable and repeatable, and trying to add in every single new thing will affect that. So make those decisions cautiously. Lastly, great patterns are measurable. And so every time you think about these patterns, consider SLAs. What is the technical success criteria for this pattern? What is the performance? What's the response time of this serverless API, for example? How much should this thing theoretically scale? So always think about making those patterns measurable. That really keeps engineering teams accountable. And then second, publishing events to measure everything else. And I'll get into that and what a revolution that's been for our business in just a second. So standardization. For team leaders, for serverless leaders, this is a big challenge. This means tapping a lot of folks on the shoulder and trying to continuously get them to move in a common direction, which takes a lot of energy, right? A lot of energy, a lot of emotional, interpersonal work, even a lot of the time. And if you're building serverless architectures, you will end up with ideally a lot of output. You'll have a lot of different software artifacts and probably a lot of code repositories at the end of the day. And so what are the simple tricks to standardize your architectural practices, in the face of this outcome? Because if you're successful, this will be the outcome, and it's a great outcome. One of the quick, best, simple suggestions that we've for you, that we've done internally, and this is a screenshot of our actual implementation, is to create a handbook. Number one thing, yes, you're going to have a lot of software artifacts, you're going to have a lot of code repositories, but make sure you keep those standards, processes, and SLAs for the patterns that you use. And maybe think of this as a kind of a pattern registry. Make sure you define those in a central handbook someplace. Put it someplace centralized, because you will end up building a lot. And this will save you a ton of time. Instead of tapping everyone on the shoulder, trying to remind them, what the best practice is, write it down, make it permanent, make it accessible, make it approachable, make it compelling and engaging to read, and then point to it. And that's all you have to do. And have your team hopefully enrich it over time as you start adopting new patterns and new services. So common patterns. Let's get into some of the basics. If you're just starting your serverless journey here, you want to implement a serverless strategy. What are some of the common patterns that you want to consider that are great fits for serverless, and how do you kind of scope those? So first off, in the serverless framework world, we have a concept called a service, and a service is basically a group of cloud infrastructure and code that powers all or part of your application. And this is often deployed as a single unit. You can see it in here. This is basically a very simple serverless service. It's declared by serverless.yaml. And what a lot of folks do is you can actually put raw AWS cloud formation in here to define other cloud infrastructure resources, in addition to using the simple functions and events syntax to define your logic and the things that trigger that logic to run. So this is a basic serverless service, and they could be scoped a variety of ways. Oh, and also most importantly, these are patterns at the end of the day. What a lot of teams do when they start off is they'll create templates of these patterns and say like, hey, what use cases, what patterns are we going to adopt in a serverless fashion? And how do we make those repeatable and scalable and do those according to best practices? Well, teams will start off with templates, creating templates and putting them in their GitHub org or something similar, and making sure that the team is aware of all them and using them as starting points for their development. But these serverless services are patterns at the end of the day. And yes, you can scope them a variety of different ways. We've seen everything here. We see a ton of monoliths. We see a ton of service-oriented architectures, kind of domain-oriented architectures, as well as microservices. Here's kind of a closer look at what each one of those looks like in serverless.yaml. So first off, we have your classic monolith. Here on the left, you have a single function, which has your entire API in it, and you're just passing all HTTP requests into that function across any path and any method. You have a router defined in code, and that's handling all the logic, and then your resources are defined down below it. Up next is kind of a domain-oriented, so a pattern. Here's an example of that, your users API, everything users and auth, you might want to put in a common service. You could practice a similar pattern here where you just have a single monolithic function. It's not your whole app, but it is scoped to this domain, as well as resources pertaining to that domain. So you might just have a users database with it. All the way to microservices. So this is what a lot of folks do as well. They have separate functions for doing single tasks, and they'll hook up different API endpoints and methods to those functions. So those functions have just singular concerns, and they don't do anything else. And so we see we've seen a ton of common patterns. I've been in religious arguments for hours on what the best patterns are. And I've, after practicing this and doing this a lot in our company for years, we've personally arrived at a pretty controversial opinion as to what common patterns should be applied to keep your architectures approachable, extensible, and repeatable. And that is, the first thing is we do practice monoliths at Serverless Inc. And it seems strange. AWS actually recommends microservices with AWS Lambda. However, over the years, we have reverted into more monolithic patterns. And that is simply because microservices, even though Lambda is more efficient than containerized microservices, they introduce a huge tax on everything. Whether it's making simple changes, a lot of changes at the end of the day will involve changes across multiple microservices. And furthermore, microservices in the serverless world often end up with shared cloud infrastructure dependencies. So I would say when I'm working with a customer or another team, or in situations where we've built something in our organization, 80% of the time, 90% of the time, what I actually run into are not true microservices and true independence, but more distributed monoliths. And distributed monoliths are just challenging because the interdependencies exist and they're not quite clear what they are, and you can fall into this pattern with serverless architectures really easily. In fact, it just seems inevitable a lot of the time if you start off with the microservice approach, in our opinion, So so over time, we've gone back to monolithic. And furthermore, there's another important reason, and that is if you look at AWS Lambda and how it's evolved, AWS Lambda, one of the most successful services at AWS, redefined how we do compute on the cloud. And I think it's kind of been a bit of a victim to its success in that they are adding new features and configuration options to Lambda every single year, a ton of them. So what you're ending up with is every single Lambda function is a separate unit of deployment, and their configuration surface area is growing and growing and growing. And the concerns that you have to think about, the cognitive overhead that comes with all that as they keep adding features and whatnot, which are great and really interesting, it's a lot of surface area for you and your team to remember. And yes, you could define all that in infrastructure as code really well, but still it's growing. And so over time, because at the end of the day, we just didn't want the cognitive overhead, we've shifted over to a monolith pattern. And because we have data on how users use the serverless framework, I will tell you, most users do monoliths with serverless framework at the end of the day. So regardless of the AWS best practice, I think it's in their AWS Lambda kind of operator or developer guide. This is what we see most people doing, and we get it. We've fallen into this pattern. So for APIs, we are a big fan of a monolith still, personally. Now, for async processes, we care more about domain-oriented. These are most often smaller in scope, and they're useful and are easier to organize around that smaller functionality. So async kind of background processes, other components of your application, we recommend domain-oriented for that. And then furthermore, one other thing to think about is as you build out each one of these services and these different patterns, over time, or maybe right from the start, you want to separate the resources that you deploy often from the resources that you deploy infrequently, in two separate serverless.yamls. Because at the end of the day, you're going to be changing your code all the time. You're going to be hopefully iterating, building out great, wonderful products that change the world, maybe a couple times a day, and you're going to be deploying them on that stack. You don't want to be deploying your database with every single time, or something DNS related, or your API gateway, or some piece of larger shared infrastructure. So you may want to consider putting that infrastructure that you deploy infrequently in a separate serverless.yaml than your code at the end of the day. This reduces chances of breaking parts of your application. Lastly, on the common patterns, this is definitely a hill that I will personally die on, and that is embrace an event-driven architecture for async processes. So being able to subscribe to events with serverless compute creates autonomy, productivity, extensibility, and creativity, and just so much more. I think what you're looking at, this very simple diagram to the right here, is the killer serverless stack, in my opinion. If you are starting, with net new and you're building something that's full stack or kind of a larger application, you are going to get so far with this, and you're going to get so much productivity out of this. So you have kind of your basic monolithic API running in a single function, and then you have and then you need to take the stance of considering everything that happens as an event and publishing that into an event bus. And with AWS Event Bridge, it's made it a lot easier. We don't use Event Bridge at our organization yet because we've been waiting a while for it to mature, and it looks like that day is finally here. So we want to adopt Event Bridge in the very near future here. But everything that happens in your application, consider it as an event and try and be overly ambitious with publishing events into that event bus. And the reasons why is that you get an incredible decoupling and approachability and productivity out of that. And it's not just about your core business logic at the end of the day, like sending a email after someone has signed up and whatnot. To tell you how we're using events. So every single thing that happens in our serverless dashboard is expressed as an event that's published to an event bus. And those events are being used to initiate asynchronous background processes as part of the core business logic. However, our product team got a hold of those events. They opened up their own AWS account and they started subscribing to those events and doing all types of product analytics. on those events as well. So all of a sudden, just by forwarding this data into the event bus, we got better extensibility on the business logic with clean decoupling. And then our product team came in and they started being able to measure our products really effectively by forwarding that data off into Mixpanel. And then our sales team got involved and they built a ton of integrations into their sales products. And our marketing team as well are building all types of integrations into those events. So the event bus, the event-driven architecture is really going to help your whole organization, the various departments of your organization, get organized around how they could kind of dive into the application and start extending it to go solve their specific problems within their domain. This has been an incredible achievement. In the early days, we always did this pattern of trying to rebuild these things in different shapes and forms without centralizing on a unified event bus. That was a huge mistake. Really consider this pattern for everything you do going forward. It is absolutely going to change not just your applications, but your entire business at the end of the day. Also, we add our events into the handbook. We say, hey, everybody in the organization, we have a pretty engineering savvy organization. We say, if you want to make something happen, here are all the events that you could use to go do great work and integrate into your other systems. One of the first things that most team leaders are trying to figure out when building serverless teams and the initial architecture is how do they separate AWS accounts? And over time, this has changed in terms of what we do on AWS. It used to be back in the old days, I don't know, 2013 maybe, you kind of have a single account and you have multiple stages and you'd be doing everything in that single account. And that was your whole world. I think Heroku actually was built for many, many years just on a single AWS account. And they didn't do anything else other than just optimize the usage of that AWS account. Then I'd say maybe 2014, 2015, we saw separating accounts per stage. And this is great for really separating and securing your production workloads, keeping that separate from your development testing environments. And this has been highly recommended for a long time. Up until now, we're seeing a lot of accounts being divided up per workload and stage now, which is interesting. And to show you what this looks like, over here on the right, you could have the business API, your auth, and the event bus all in one AWS account. Separate your event handlers on another AWS account, and other parts of your architecture on another AWS account. What's the big benefit of this, which is what we actually recommend here? A lot of it's just not having shared resources on the cloud infrastructure account. You just have a cleaner boundary around everything. And at the end of the day, identity and access management on AWS, and practicing things like principle of least privilege is important. And we highly recommend it. But it's hard. It's hard to get teams to practice that perfectly and maintain that over time. There's such a difference between setting things up initially and maintaining them over the long run. However, if you just start separating workloads into AWS accounts, you just immediately reduce the risk radius of a security incident, of somebody kind of getting access to something and being able to get into other parts of infrastructure in an AWS account and do nefarious things. So we do recommend now separating accounts per workload plus stage. And furthermore, this you want to enable your developers to have their own AWS accounts so that they can quickly spin up these parts of the serverless architectures on their own AWS account and develop with autonomy. One of the big challenges with developers working on serverless architectures is collaborating on shared cloud infrastructure is really hard. So we recommend spinning up developer accounts. Each developer has their own developer account. They can work with a lot of autonomy in there, not trample on anybody else. And then when they're done, kind of push things to an intermediate or test or staging account. And that's where you can run all your tests against it before promoting into production. But the trick here, if you really want to enable this type of workflow, is to keep your distributed systems more monolithic. So this is one of the big reasons why we also recommend monolithic APIs and whatnot. The less infrastructure complexity, the easier it is for a developer to kind of spin up a big, important piece of your application on their own AWS account. The more infrastructure complexity, that gets a lot harder. So especially with APIs, your developers are working on that stuff all the time. They're always iterating on that. It's another reason why we went back into monoliths, is because our developers could quickly just deploy that singular monolithic function on their account and the few other shared resources of that, as opposed to a whole bunch of microservices and all their other infrastructure dependencies and permissions and whatnot. It just became a big source of friction for us. So development, getting into developer workflow. So I talked a little bit about it here, and enabling developers and allowing them to move quickly with their own AWS accounts. But there's another big principle that we've come to over the years. This one might be controversial, but I'll tell you, I've seen thousands and thousands of projects. And there's definitely still a difference between what the best practices are that people recommend and what's happening on the ground today. And that is, like how do developers develop in a way that they can collaborate without trampling on each other, that they could do, develop and make changes safely and do so at a high velocity with a lot of autonomy. So if they have a vision, they can go pursue it without getting blocked. So our big suggestion here, which is a bit different from some of the other practices out there, is to develop in the cloud. And the reason for this is local emulations are really hard to maintain as projects and teams scale. I've seen a million teams start off with a local emulation, and it's just a couple developers, and the project is very simple. It only has a few services. It's probably like an API or a simple microservices architecture. You can get far with a local emulation if you're at that stage. But fast forward a couple years, you have some attrition on the team. You've brought in, but at the same time, so you've lost some contextual knowledge, but at the same time, you've brought in a lot more teammates. So you're scaling that team. And then you've brought in more serverless services. And all of a sudden, those emulations tend to become these Frankenstein beasts that development teams spend so much time maintaining that they're kind of losing all the free time they're saving by adopting serverless architectures in the first place. And so it's easy to start with offline. And if that works for you, if you have a small project and a small team is going to be that way for a while, and you got a high velocity and it's working, go for it. But I'll just tell you, down the line, it always turns into this kind of Frankenstein beast that leaves a lot of the developers with just this distaste in their mouth for serverless architectures, because they're just like, we can't get the local emulation up and running. It's really crazy. And I guess at the end of the day, serverless, the way the cloud is moving, development has to move over to the cloud, in our opinion. And we're working on a lot of things to make that better in the upcoming Serverless Console, in the existing Serverless Framework dashboard. Wait till you see what Serverless Cloud can do. It is the best serverless on the cloud development workflow, but at the speed of local. And it's taken years of engineering to make that happen. So developing in the cloud, it's the way forward. We're big believers in this, and monolithic APIs, single purpose async tasks will really help your developers deploy, bring that stuff into their own AWS account, and there they could develop in the cloud. Practically with Serverless Framework, we'll see people do CloudFormation-based deployments. That's the serverless deploy command 2% of the time, but most of the time developers are just doing deploy function. And if you use deploy function, you're going to push changes into the cloud in like a couple seconds, basically based on your internet connection speed. And you could get really far. You could have a very fast, productive workflow just using that simple methodology. Streaming logs also using serverless logs with the tailing feature in your terminal on your own AWS account allows you to move forward with a lot of autonomy. So over time, yes, develop in the cloud. That's where we've ended up. Up next, AWS account access management. Dedicating AWS accounts to specific domains and stages can be hard. We just talked about what the industry trend is for separating AWS accounts, per workload, per stage. If you look at AWS's well-architected framework, you'll see that they recommend separating AWS accounts per workload per stage now. So this is the new consensus, the new best practice the industry has converged on. So now you're going to end up with a lot of AWS accounts. And how do you assign those to specific parts of your application, specific stages? How do you really corral all that and make it seamless for a developer team so they don't get hung up on trying to get AWS account access management? They need to go pursue their vision with the least amount of friction. So number one, that's a big challenge there. Additionally, how do you protect production accounts, production workloads? That's a huge challenge when it comes to this world of increasing AWS accounts that we've entered into. How do you prevent not leaking long-lived access credentials to those accounts? You have a lot of accounts, all of a sudden the opportunity for leaking long-lived credentials is growing. And how do you easily onboard and offboard teammates? If you are using all these different AWS accounts, all this stuff kind of gets a lot harder in this world. So like this is where Serverless Framework Dashboard, this is like one of the first things people do in Serverless Framework Dashboard. It's one of the first problems we solved. Can't recommend it enough. The Serverless Framework and its dashboard can sit on top of 1 or 1,000 or more AWS accounts. And those, it's going to enable you to set up access management and assign AWS accounts really easily, which I'll show off right now. It's also going to enable you to protect production accounts that could be deployed with basic access keys using CI/CD. So you want to promote to production using an automated deployment process that no individual developer touches. Serverless Framework helps out with that. It's also going to help your team only use temporary access credentials. No one should have long-lived access credentials. And it's going to help you onboard and offboard teammates. And without further ado, I'm going to jump into the Serverless Framework dashboard right here. And here's a brief glimpse at one of our organizations in the dashboard. You can kind of see we have just a bunch of services in here, almost totally consistent names, but still a bit of work to do there. So here's a demo application that that's in my personal organization. And you kind of see how I've divided up these different services across my app. And here you'll see that there's a dev stage, there's a staging stage, and there's a production stage. So of this instance of this service, effectively. Now, each one of these is deployed to a separate AWS account. And one way that Serverless Framework Dashboard makes that really easy is our simple providers concept. In here, you could easily link a AWS account using an IAM role in that AWS account. So if you go through the little wizard here, it'll set up an IAM role in your different AWS accounts and do a simple CloudFormation-based deployment and quickly detect that IAM role. And here you could assign, you want to name those IAM roles after kind of what the workload might be and what the stage might be at the end of the day. So here, this is a very simple setup. We have teams that have dozens and dozens of AWS accounts in their organization, and just doing this upfront in the beginning is going to save you so much time. And make sure you get the naming consistent. Consistent names really help teams navigate stuff without needing a lot of help. Furthermore, you can assign a default AWS account for the entire org if you want to, and that's great as well. And to show you what this looks like in practice, so here in my serverless.yaml, as long as I'm signed into the dashboard, here I'm in my AC360 organization, I'm logged in already. I don't need to have AWS access credentials on my machine. I don't need to have them, don't need to have long-lived access credentials, don't need to have anything related to AWS at the end of the day. I just need to use Serverless Framework. And in here, by default, it deploys to a dev stage. So without having AWS account credentials locally, I could quickly deploy to this dev stage, because if I go over here and I go over to my REST API and I go into the dev stage here and I click on providers, I can see that the personal dev AWS account is assigned to this stage already by default. And furthermore, we do this handy little thing where we could say if it was an inherited provider, You could override these providers on the specific stage, but you may just want to have a shared development account where people can deploy into, everybody can deploy into, and set that as the default. So that's what I've done here. And upon deployment, Serverless Framework actually reaches out to the dashboard. The dashboard then reaches out to the correct AWS account based on the stage I'm using. The dashboard uses STS to generate temporary credentials that only last for 20 minutes. Those credentials are passed back into the framework, and the framework uses them to do the deployment. As a team member, I don't need those AWS access credentials. I don't need long-lived access credentials on my machine. All I have to do is just sign into the dashboard, and I'm ready to go. This pattern scales across a ton of AWS accounts. And then, of course, you could go back and look at my staging stage. In here, I've actually overridden the default provider with my staging AWS account. And then, of course, in the production stage, I've done the same. The production stage should only deploy to the production AWS account. And so here you've got a same default you could implement for your organization, and then you could override it with specific accounts that are meant for production workloads or staging workloads for testing and whatnot. And then lastly, here in the team settings, I've got a few people from our company added to my personal org. Can't remember the reason why I added these folks, but here they are. To onboard and offboard these folks, to onboard people is really simple. You just add them to the organization and assign them different roles here. And then to offboard, if you do run into that circumstance, or maybe you're working with a temporary contractor, you just remove them. And so I'm going to remove our VP of product, Maciej. No hard feelings, but I just took him out of my organization, and now he has no access to the applications in my organization, and of course those AWS accounts at the end of the day. So this is, first things first. If you're starting to scale out a serverless team, can't recommend this enough, and it's going to simplify so much. All right, so I'm going a bit over on time. I'm still going to hang out and do 15 minutes of Q&A. I should probably wrap up in about 10 minutes here, and then I'll jump into that Q&A. And so even though I'm going over in time, I'll just let you all know that, as long as you have the time, of course. Up next, structuring code. AWS Lambda is a unique and unusual environment. You're dealing with these new concepts. It's not a virtual machine. It's not a container. You're dealing in this world of functions and events with context and statelessness. It's a bit different. And so what we see a lot is teams will start to write their own Lambda-based application framework in their Lambda functions. And be careful of this. This is going to create complexity and maintenance and education burden for everyone else, because now all of a sudden your team is in the application framework, kind of runtime framework business, which you don't want to be. You want to be focusing on product, right? The whole purpose of deploying using serverless was to reduce overhead, not create overhead. Also that you could focus on product. And so at the end of the day, we kind of fallen back on community-driven frameworks and standards for structuring code, especially for APIs. So at our organization, we're very big fans of classic Express.js or Apollo for GraphQL. Python, there's Flash, there's a great Rails implementation on top of Lambda. And a lot of these classic frameworks, even though they were designed for stateful, kind of serverful environments, they work very well on Lambda. Not all the features are going to be there, but for the most part, you'll get super far. And now you have something that's predictable and consistent, and you don't have to think about building a new kind of application, kind of runtime framework as a result. And I'll tell you, I've worked with a ton of teams. I've seen the craziest frameworks that teams have built. And over time, it always seems easy at first, but if you're a leader, you're thinking about the maintenance, not just the initial upfront cost. You're always looking at the long-term carry cost. Also, there's Lambda API. Lambda API is a simple app framework it's kind of like Express, but for Node.js runtime-based Lambda functions, but just designed better for a Lambda. Lambda API is created and maintained by Jeremy Daly, a popular serverless podcaster and community figure. Go check him out on Twitter. You can just search Jeremy Daly. But also he works at our company and he's the general manager of our new Serverless Cloud project. And all the stuff he learned from Lambda API and all the best practices he's picked up over the years, he's incorporated into Serverless Cloud. There's also MIDI.js, which is a great framework, community-driven standard for just having a simple middleware concept for your Lambda functions. But highly recommend this. You don't want to be in the business of writing those application frameworks. Furthermore, if you start breaking up your applications into multiple services or microservices, or you just have multiple apps over the long run, you got to think about maintaining the consistency across these functions in the output, as in pagination, especially for APIs. Those community-driven standards will help a lot if you go with that. But of course, you still have to think about what does the typical response look like for your API, especially when it comes to returning errors from your API or pagination. You're going to want to standardize all that. And furthermore, for errors, if you want to report errors and print errors in a common way, and if you can decorate them, it's going to make a big difference for you if you decorate them with contextual information. So our big suggestion here is simply to create a shared utility library. This is kind of also one of the key patterns you should adopt right from the onset, and that's this shared utility library that offers a standard format for maybe how your API returns responses, for how your APIs do pagination, as well as how you print errors. So this shared utility library is just a code library that you could package in a concept called an AWS Lambda layer. And that's basically just a simple, convenient way to ship some code always with your different AWS Lambda functions so that it's always there. You could version layers and whatnot. But this is really going to help your team because if you get everything else right, you'll run into APIs returning inconsistent things, weird error reporting issues. And so in this shared utility library, you should consider making utility functions that make standardizing all these things a lot easier. Furthermore, on the logging side, troubleshooting, you want to think ahead here when it comes to making it really easy for you and your team to troubleshoot issues, especially in production. And of course, if you just have no logging standard, randomly written, formatted logs from your teammates can be really difficult to understand. And furthermore, there's a lot of great monitoring tools these days, which will allow you to query across your logs, but they can only do that if your logs are in a structured format. And you're going to want those query capabilities. So our big suggestion here is to structure logs in JSON format. Put this practice in place right away. This is what our format looks like on the right. It's pretty simple. It's actually an event format because a lot of our logs end up being events too. And so there's just a simple event name or type at the top, and then there's some data that's associated with it. Don't put sensitive information in there. Of course, you never want to do that. But here you can kind of decorate your logs with important custom, customer information, customer tags, and whatnot. And again, by using that shared utility library, make some simple log utilities for your team that makes structuring logs easy, or printing structured logs really easy. So a lot of the stuff, if you get the utilities right, this can just, people should just be able to require in the shared library, and you could even, override the log function if you want to go that far. But make it easy for your team to do this because you're going to be so happy when you run into that big issue in production, that first big issue, and unfortunately the millions of issues that probably await if you're building software in the real world. So this is huge. And then of course, with this structured format, decorating it with tags, you could actually search across that stuff, query across that stuff in the serverless framework monitoring dashboard, as well as use something like CloudWatch Logs Insights to go query across logs based on customer ID, other contextual information that just wouldn't normally be there. So we're a huge fan of this. Again, that utility library, this is a great place to put that stuff in and make it easy for your team. Lastly, a quick note on monitoring. And I'm trying to move along quickly here. Centralizing monitoring, logging, troubleshooting across a lot of cloud infrastructure and AWS accounts, incredibly difficult. We already talked about how the trend of increasing numbers of AWS accounts is the reality today. And of course, with serverless architectures, you're going to have these massive distributed systems with a lot of cloud infrastructure. So how the heck do you get a single pane of glass view as to what's going on there? It's super, super hard. And then furthermore, setting that up again is easier than the maintenance over the long term, right? Because again, things are going to change, teams are going to change. And how do you make sure that the instrumentation, all this stays in place so that whoever is in charge and accountable for those metrics can do their job with with a high degree of faith. So look, this is one area we spent a lot of focus on in the Serverless Framework dashboard. We really, Serverless Framework dashboard sits on top of multiple AWS accounts, and we've done a great job centralizing all the important information, monitoring metrics, alerts, logs, and troubleshooting capabilities across all those AWS accounts. And so furthermore, the framework instruments and monitors everything automatically. So you just deploy with Serverless Framework, it's going to do a lot, use a lot of built-in intelligence to set up things for you. And it's always going to do this across many AWS accounts. And if you are accountable for those metrics for uptime at the end of the day, this is huge. A tool that does the instrumentation automatically is the difference between you being confident in the metrics and you having to spend time every single week tapping people on the shoulder saying, is that thing still instrumented correctly? Are you sure that's working right? Because you just don't want to be doing that. That's a massive carried cost as your architecture grows. And if you've managed large teams and large projects, that I'm sure this rings too true. I mean, I'm the CEO of our company. I'm accountable for a lot of these metrics, and I've got to stand in front of a board of directors, our investors, and show them our metrics, our SLAs, our uptime in front of big customers. And I need to believe in that. I need to know it's accurate. And so just the automatic instrumentation is key. As long as the developers use Serverless Framework, this will be instrumented automatically. Furthermore, alerts are instrumented automatically with Serverless Framework too. We kind of know what your architecture looks like. And so we put a lot of smart alerts in place by default. Again, this is fantastic to just make sure that things are, your kind of observability strategy is maintained over time. And lastly, Serverless Framework gives you probably the fastest querying experience across all transactions to troubleshoot issues. And let me jump into a quick demo, and then I will start doing some Q&A here. But here you can see, let's go into maybe my staging application. So here you can see I've got some requests coming in. We start off with kind of a high-level overview of API requests, function invocations, requests by endpoint, invocations by functions. This is a very simple serverless project right here. There's really only one function and endpoint in it at the end of the day. It's pretty straightforward. And furthermore, you could do a deep dive and look at an API endpoint view. So automatically, all your endpoints will be submitted into the Serverless Framework dashboard, and you can see everything on a per endpoint basis. Furthermore, functions, you can see all your functions right here, your individual functions, behaviors. Automatically, no instrumentation. It just works. So by default, this is set up for you. Second, the best part is when you see that issue, you see that error, you can click on it and go into our Explorer. This is going to query across API requests and invocations at light speed. You're not going to get this from CloudWatch. And we're not big fans of the latency of a CloudWatch at the end of the day. Up to 30 seconds to just get basic information in and start, generating alerts and whatnot. You want to know about this stuff before your customers report it, basically. So speed when troubleshooting is key. And so we give you this lightning fast query experience. You can search across status codes, whatnot, durations, and invocations. But when I click that chart, it actually set up the queries for me. So I could see right here that the status is rendering a 502 code. And so I could see those 502s when they kind of came in here, what endpoint and whatnot, and then click it to drill in to get infrastructure details, as well as the stack trace and the logs right here. Furthermore, we have span information, so we'll automatically instrument what your function is doing and show you the different services that it's interacting with and the latency of each of those operations. But this whole flow here, starting at the high level, being able to recognize what the issues are or coming in from an alert, and then clicking through to the Explorer, having that really fast query capability, adding in some tags to search by customer ID, for example, in the Explorer. This is a lifesaver across many AWS accounts, a lot of cloud infrastructure. You want the speed, you want to be able to solve those issues before customers report them. And furthermore, our query capabilities here are so fast and convenient that many development teams use them in development. So it's a huge use case for just basically developing in the cloud. If you really want to get clear, centralized information as to whether your code worked, this is a fantastic way to do it. So here you could kind of click on and see cold starts, different errors, maybe some timeouts if I have any. It doesn't look like it, but it is a wonderful tool to use in development and really understand how to improve your code. All right, I covered a lot of ground here pretty quickly. Hopefully there's something in there that was a useful takeaway for you as you serverless team leaders. Think about scaling serverless teams, trying to start right, as well as bring kind of mission critical applications into production. Now, furthermore, with Serverless Framework, just so you know, we do have a great support offering bundled with the dashboard itself. And if you are about to hit that moment in time where you're scaling your team and you want to get standards in place, and you need to make sure you have the monitoring and troubleshooting, metrics that you could have faith in, so that you could deliver reliable software. Our dashboard package comes with a great support package, and you can, it basically takes the form of Slack. And so we bring you into a Slack chat room, and you can go ahead and just chat with our engineers, our support representatives, our account representatives right there in real time. And the support covers Serverless Framework Dashboard, Serverless Framework Open Source CLI, Serverless Framework plugins. There's a massive plugin community for Serverless Framework with over 2,000 plugins. And it also covers just general serverless architecture support. So if you have questions about serverless architectures, in general, best practices, and you want kind of feedback from people who do this every day and have probably done it for way too long, there's nothing else on the market like it. To be able to get that kind of real time, we do have SLAs that ship with that support agreement, but Slack is typically really fast to just ask questions, get that good feedback. So that's included in our starter package for the dashboard, just so you know. So with that support, with the dashboard to put standards in place, it's a pretty awesome deal. And I could actually share I believe I could share the link. I'll just put it in the chat room here. If you want to chat with our sales team, and actually some of our engineers as well, if you have questions about your general serverless architectures, in general, reach out to us, chat with us. We love going over architectures. We love talking about it and figuring out how we can help. That link will get you to schedule a meeting with us right away. I might be on that call. I love chatting with customers. I still chat with a customer at least once a day on a sales call. Keeps me closer to the truth, in my opinion. So reach out to us. Someone asked if there's a Discord. We have a serverless Slack channel, a community Slack organization. You could find a link to that on our website. There's 5,000 people in there, I think. There's always people in there. We help out a lot in there as well. There's also a Gitter channel. I think there's 5,000 or 6,000 people in it. We have a serverless forum. We have serverless.com, serverless framework GitHub issues. There's like 6 years of information in there. Our blog, a ton of resources that we offer for free as well to help you on your serverless journey. So with that, I'm going to start answering some of these questions. And wow, there's quite a few in here. So I better take a sip of coffee, and I'm going to sort these by upvotes. Okay, so first off, the first question is, may we have that diagram, SLS architecture, typical SLS architecture. So the diagram that they're asking about is this one. And this is a wonderful diagram, again, by one of our partners, theauto.com. They're great if you want a consulting service to help you build this. This is one of the best I've seen. You probably heard from my talk that I would decrease the quantity of Lambda functions in here, for the reasons that I went over at length. But overall, this is kind of one of the best that we've ever seen. Maybe Steven or someone else in the chat can find the Medium post from Theodo that shows off this serverless architecture. Again, just search for serverless, typical serverless architecture, Medium, and Theodo, and Google should pull it up there. Let's see. Someone else says, can you clarify what you mean by monolith? Do you mean a single service with multiple Lambdas behind API gateway? Or do you mean having a single Lambda function to serve all API routes? I mean the latter. So we are increasingly just adopting plain old, perhaps boring Express.js. And we put that in a Lambda function, and we're just passing through all API requests directly into that function, and handling routing in the runtime. Again, it's a very simple architecture. You could actually port it over to different technology stacks if this doesn't work out for you. So it's a great starting point. From my perspective, most people start with a monolithic framework when they start their serverless journey anyway, and they tend to stick there. Now, you have some great options where you could slowly use that. If you want to break that apart over time, you could use that API gateway to start pointing routes at different functions, which might have microservices or different domains. So there's just a ton of options to get out of that. But we recommend it as a starting point, and it's going to get you really, really far. And again, it's so easy for your developers to deploy that into their own AWS accounts, develop on the cloud, make changes really quickly without having to deal with a ton of infrastructure complexity. So that is what we mean by monoliths. Jonathan asks, is there a way to handle canary releases with Serverless Framework? Yes, so there are a lot of ways to handle canary releases with Serverless Framework. If you're using microservices, for example, you could actually have your API gateway point at different versions of a microservice simultaneously with different weightings. So you could slowly phase in another microservice. We're big fans of going back to monolithic and simply doing feature flagging. And we don't really use anything for feature flagging in the organization at a vendor right now. There's some great ones out there. We've just kind of rolled our own simple ones. And we use environment variables in Lambda to simply toggle that feature kind of on or off, or we'll write a custom weighting in there as well. At the end of the day, I think some of us at least on our team, I've heard customers echo this as well. But if you're dealing with complex deployments to handle the canary rollout, and something goes wrong, God forbid, CloudFormation gets hung up and you just get stuck in a rollback state. I'm sure if you've been doing serverless development or AWS development for a few months, you've been in that place where you've tried to roll out a big deployment and CloudFormation gets hung up. So we practice feature flags. We like to test in, kind of do a lot in production if possible, thanks to feature flags, and use environment variables, because it's a very simple configuration change to add an environment variable as opposed to doing a whole CloudFormation deploy. And that will simply help you test out new logic pretty easily. But there's a bunch of patterns between actually doing different weightings at the API gateway level, pointing to different microservices. You could still have a monolith and kind of perhaps do different weightings of that monolith using that same pattern that I described earlier. But feature flags, we're a big fan of that personally. Jonathan asks, I already went over that. Federico asks, what is monolith in the context of serverless one YAML file? Yes, typically, one practice I went over earlier was if you're going to do a monolith, you still may want to separate the resources that you deploy frequently from the ones you deploy infrequently. And again, you don't want to be deploying your database, via CloudFormation every time you make a code change. There's just, higher risk of someone mistypes something or a weird configuration change gets in there, and you're just trying to add maybe a log statement to your code, but meanwhile you just affected your database. There's just no reason that should happen. So even if it's a monolith, you just have you want to put your code maybe in one serverless.yaml, and your infrastructure that's deployed less frequently, databases, maybe even your API gateway, which you could reference in your initial serverless.yaml, storage buckets, all that in a separate serverless.yaml. So that's what we mean by monolith and dividing that across serverless.yamls. Golang framework suggestions. I'm not the resident Golang expert on the team, but we have a ton of them in our Slack channel. We do practice a lot of Go in our architecture right now, specifically for real-time streaming data architectures with Kinesis. So ingesting, processing a lot of records. We do favor Go for that. That is something that you'll have to just ping us in Slack about. And some of the Go fans will jump in and help out with that. Federico asks, given the premise of having one account and developer within your org, how would you handle the potential risk of having any given developer drive up the AWS bill because they mistakenly set up something expensive? For example, a 10 gigabyte Lambda with a 1K provision concurrency. Yes, so this is a risk. You can drive up large AWS bills. With some of the event-driven architecture stuff I've been talking about, it is great power, but with that comes great responsibility not to DDoS yourself with some type of infinite loop. And it can be easy to do that. This is really powerful, very easy cloud infrastructure, which you can make mistakes more easily, just as easily as you can make a great product. So how to reduce the AWS bill? Serverless Console, our upcoming solution, monitoring and operations console, has some great solutions for this. It has, I guess you can't see it in this view, but there are cost estimates that are reported in real time. There will be alerts for those cost estimates as well. So the alerts are going to be key there. That's going to be a big part. So we are releasing a lot of that in Serverless Console because people need better cost controls and cost understanding in this. Furthermore, look, the more cloud infrastructure you have, the more configuration surface area you have to be concerned about. And so in this example, where you have a Lambda function, again, I've been kind of harping on the monolithic pattern for a while here, but this is one of those reasons. Lambda has never had more configuration options. There's all types of stuff you could do on Lambda, and you have to really kind of pay attention to that closely. And that gets a lot harder when you've just made 5,000 Lambda functions, right? It's going to be much easier to do a 1K provision concurrency and a 10 gigabyte Lambda. If there's 1,000 Lambda functions out there, you just can't, you don't have that great oversight as to what your team is doing and whatnot. We will get into this in Serverless Console in the near future of just putting some simple standards and safeguards in place that should prevent against this. But for the most part, consider creating templates that are easy for your team to consume, and make sure you have a review process, of course, before you promote that into production. And then some of the default limits for the cloud services should help you on your journey as well. Okay, Adam asks, thoughts on deployments to AWS Greengrass via Lambda. The serverless.yaml file also defines Greengrass environment and local runtime requirements. Adam, I'm not a Greengrass expert. And to be honest, it's been a while since I've spoken with customers who are doing a lot of Greengrass. So you have to reach out to us in Slack and our Slack organization to ask more about this. Maybe Gareth on our team has more experience with Greengrass, but I'm just not the right source of information on that topic. Sorry about that. Vitaly asks, how do you deploy stateful app on a serverless platform? Well, there's a lot of different ways you could manage state in serverless architectures. You have stateless compute, but there's a ton of solutions for state at the end of the day, from using step functions, which is basically a kind of a state machine for serverless. It's great for workflows that want to share a state over maybe a long-lived operation. That's really useful. Otherwise, DynamoDB for basic persistence is what we see 70-80% of the time in most serverless architectures. DynamoDB is wonderful for really low overhead and low maintenance. And going back to this this basic serverless architecture here that I was suggesting, let me go a little bit further. That I was suggesting is just probably just one of the best sets of patterns that you could have. You know, your business API, your event bus, your asynchronous event handlers, your shared utility library. You know, what's becoming increasingly popular in DynamoDB domain right now, and in serverless architectures is a single DynamoDB table design. So having your single DynamoDB table and kind of your monolithic serverless API, it's really low overhead. It's a lot of infrastructure simplicity come with that, and it's just tremendously easy to manage all that in production and scale it. So we practice a single table design in our organization. There's a lot of great resources on how to do that in DynamoDB. So we see that increasingly right now. And again, if you're into low total cost of ownership, we highly recommend it. Okay, got quite a few questions here. I might have to take some time offline to follow up with all these, and I hope this webinar platform can help me out here. But I might have to go ahead and end it there because I've gone almost 30 minutes over time. This video will be published on YouTube, so we will be setting it up to YouTube, and hopefully you could see it in a day or two and review it. Again, I hope a lot of this was helpful. These are hard-won lessons, and again, kind of going back to this controlling idea that I started with, and that's, look, if you're leading a team, you have to think at the pattern level. That's really important. If you're adopting serverless, think about the use cases, think about the patterns that you want to leverage it for. Serverless is so good at a ton of use cases now. It's never been a better time to adopt serverless. The technology is mature. I can't speak to new AWS services that have just been launched and will be launched next month, but this is a fantastic time to get serverless. The cloud is only going to get increasingly serverless. So it's a good idea just to get started on it right now. But as a leader, you have to think about the whole picture, the patterns. You have to think about reducing total cost of ownership, not just in the technologies and patterns you adopt, but for the team workflow as well. You have to look at across all these different prisms. And if there's one takeaway that I'd love to leave you with, it's this one. So we'll post this up to YouTube shortly. Again, if you want to reach out to us and chat about the Serverless Framework dashboard package, which includes a fantastic support offering, here's the link. You can schedule a meeting with us today, I think. And we have some more webinars coming up. And by the way, in October and November, we're launching a ton of product stuff we've been working on for a year. So follow us on Twitter, follow us on serverless.com, sign up for the newsletter. It is just a fantastic time in serverless land. And again, these are the greatest building blocks of all time. So we hope you go and make something really meaningful and impactful in the world. Okay. Thank you, everyone. Take care.